Students, let's discuss exercise 13.5. First sum. A copper wire 3 millimeter in diameter is wound about a cylinder whose length is 12 centimeter and diameter 10 centimeter so as to cover the curved surface area of the cylinder. Find the length and mass of the wire, assuming the density of copper to be 8.88 gram per centimeter cube. Actually, here we need to find out the length of the wire, length and mass of the wire. So see here, the diameter of the copper wire is 3 millimeter. Okay. At the same time, the diameter of the cylinder is 10 centimeter and the height of the cylinder is 12 centimeter. So to find the length of the wire, number of rounds in a circle. Okay, so to find length of the wire, so first we need to find out a number of rounds of wire in the cylinder. So for that, we know that what is the total height of the cylinder is 12 centimeter. Okay, then we know that the diameter of the wire is 13 millimeter. Okay, this 13 millimeter convert into centimeter, so that 0.3 centimeter. And the next, divide the height of the cylinder and divided by the diameter of the wire. Okay, if we divide means easily we can find out number of rounds. Okay, so totally height is 12 centimeter, so one round is 0.3, then next round 0.6, like that it is going on. So easily we can find out, so totally how many rounds it contains. So height of cylinder divided by diameter of wire, so 12 divided by 0.3 is 40 rounds, so the number of rounds is 40. Next we need to find out the length of wire required for one round. Okay, so then only we can find out the length of 40 rounds. So length of one round, see this, that is looking like circle. See this is circle. So we know that the circumference of circle, okay, circumference of circle is 2 pi r. So here what is the radius? Radius of the cylinder is 5 centimeter. So the length of wire required in one round is 2 pi r, 2 pi into pi, so 10 pi. So the length of wire required in 40 rounds is 40 into 10 pi. So the answer is 400 into 22 by 7, pi value 22 by 7. If we simplify, we'll be get the answer as 1257.14 centimeter. So here we found the length of wire in 40 rounds. Next we need to find out the mass of wire. So mass of wire, before we need to find out the volume of wire, because we know that the mass equal to volume into density. So that is mass. So for that, first we need to find out the mass of wire. Sorry, volume of wire. So already given the radius of the wire. So the radius of the wire is 0.3 centimeter or 3 millimeter. Okay, so that is diameter. Diameter of the wire is 0.3 centimeter. So that radius is 0.15 centimeter. So we know that the volume of wire equal to area of cross section of wire into the length of the wire. So we know that the wire is looking as cylinder shape. So we know the formula. What is the formula for cylinder? Pi r square h. So that pi r square is area of cross section, that is circle shape, and length of the wire is height. Okay. So the area of cross section is pi r square, and into length of the wire already we found. So what is the length of the wire? 1257.14. Then simplify, will be get the answer as 88.898 centimeter cube volume of wire. Next we need to find out the mass. So mass equal to volume into density. So the volume is 88.898 into density is 8.88. If you multiply these two, will be get the answer as 789.41 gram. So here we found the length of the wire and mass of the wire. Students, let's discuss exercise 13.5 second sum. A right triangle whose sides are 3 centimeter and 4 centimeter other than hypotenuse is made to revolve about its hypotenuse. Find the volume and surface of the double cone so formed. Here given two sides of the triangle, one side is 4 centimeter, the another side is 3 centimeter, and the hypotenuse is not given, but the right triangle is revolved to make a cone with the help of hypotenuse. So here we need to find out the volume of these two cones and the surface area of these two cones. So for that, first we need to find out the height of the cone, height and radius of the cone. So how to find out the total height of the cone? Here we cannot find out that AO, OC separately because we know only the slant height, that is 4 centimeter. Okay, but we can find out. So already we know that the triangle ABC is a right angle triangle. This angle is right angle. Okay, the angle B is right angle. So the angle AC is, we know that hypotenuse. So by using Pythagoras theorem, we need to find out the height or hypotenuse side of the triangle. Okay, AC. So we know that the hypotenuse side square equal to sum of squares of other two sides. So hypotenuse is equal to square root of 3 square plus 4 square. So AB square plus BC square. So hypotenuse will be 5 centimeter. Next we need to find out the radius OB. So this OB is perpendicular to AC. So directly we cannot find out this OB. Okay, if we know the value AO, we can find out OB. But we know only the length of AC. So directly we cannot find out. But by using the right angle concept, we can find out OB. So see, this OB is perpendicular to AC. So we know that area of right angle triangle is half into base into height. So see this half into, just to take this triangle AC is a base, OB is side. So half into AC into OB. So for the same triangle, we can find out the area by using another way. So for that, we can take BC as base and AB as height. Okay. So here see this half into 4 into 3. So the area of this triangle, if you finding to any method, will be get the same answer. Okay, so to find OB, I used some other method. So already we discussed about in ninth standard. So first here I used OB is height and AC is base. Next, I used BCS base and AB is height. So off into 4 into 3. So after simplification will be 6. AC value we know that 5. So except OB, remaining all the values transposed right answer, that finally will be get 2.4 centimeter. So here we know the radius. Radius is 2.4 centimeter and we know the height. Okay, total height is 5 centimeter. So now we can find out the volume of the cone. So we know the formula for volume of the cone. 1 by 3 pi r square h. So volume of double cone equal to volume of cone 1 plus volume of cone 2. So volume of cone 1, so 1 by 3 pi r square h1, that will be differ. 1 by 3 pi r square h2 the second cone. So already we know that h1 plus h2 is 5 centimeter. So remaining things take as common and h1 plus h2. h1 plus h2 the value is 5 and we know the radius is 2.4 centimeter and pi value. Then after simplification will be get, so the answer is 30.14 centimeter cube. Next we need to find out the surface area of double cone 2 cone equal to surface area of cone 1 plus surface area of cone 2. So upper cone plus lower cone. So we know the formula pi r L1 plus pi r L2. So substitute the values in the given formula. So we know the slant height 4 plus 3. So after simplification, the answer is 52.75 centimeter cube. So the surface area of double cone is 52.75 centimeter cube, centimeter square. Students, let's discuss exercise 13.5 third sum. A system internally measuring 150 centimeter into 120 centimeter into 110 centimeter has 1,29,600 centimeter cube of water in it. Porous bricks are placed in the water until the cistern is full to the brim. Each brick absorbs 1/17th of its own volume of water. How many bricks can be put in without overflowing the water? Each brick being 22.5 centimeter into 7.5 centimeter into 6.5 centimeter. So here given a system internally measuring. So you know that that is a water filling tank. Okay. So it is looking like a cuboid shape. At the same time, the tank has 1,29,600 centimeter cube of water in it. So here we need to fill some bricks inside. But here given one condition, the bricks can be put in without overflowing water. Okay. At the same time here given the dimension of the bricks also. The bricks can absorb 1/17th of its own volume. Okay. Suppose if you put inside one brick, that one brick can absorb 1/17th of water. So already we know that if you put inside the bricks, definitely it will absorb some water. That is only here given. So here we need to find out how many bricks can be put inside the tank without overflowing the water. Okay, so for that first we know that what is the volume of the tank, that is cistern. So the volume of the tank is, so length into breadth and height, so the volume is 19 lakhs 18,000 centimeter cube. So first here we found the total volume of the tank. Next we need to find out the volume to be filled in cistern. Okay, so already they given, so 1,29,600 centimeter cube of water in the tank. So next we need to find out so volume to be filled in the tank. So for that we need to subtract that volume of water from the total volume of the tank. So volume need to be filled 18 lakh 15,400 centimeter cube. Okay. So next we need to find out the volume of one brick. So the volume of one brick is 1096.875. So the bricks we know that that is also looking like cuboid shape. So that is one volume of brick. Actually here we need to find out the number of bricks can be put in the water without overflowing. So we don't know that. For that purpose only here I took that number of bricks, so n into. Okay, so for that purpose only multiplied here n. This only we need to find out here. And one more condition is given. So each brick absorbs 1/17 of its volume. So here we need to multiply by 117. Okay, if you multiply by 1 divided by 17 will be get the volume absorbed by the bricks. Okay, if you multiply by 1 divided by 17, that is the volume absorbed by the bricks. So here I multiplied by 1 by 17. So the answer is n by 17 of 1096.875. Okay, so this is volume of water absorbed by number of bricks. Okay, according to the condition, we know that the volume to be filled in cistern or the tank plus 1/17 of its volume, 1/17 of its volume of bricks, n bricks. Okay, we don't know that how many bricks. So sum of the volume to be filled and the number of 1/17 of its volume of water absorbed by the bricks equal to volume of n bricks. Okay, so these two volume equal to the number of, that means volume of n bricks. These two are equal according to the given conditions. So by using this condition we can find out the number of bricks. So for that this n by 17 of 1096.875 transposed to right hand side. Then take LCM and simplify. So we'll get the answer is 16n by 17 of 1096.875. And the next step, except this n, remaining all the values transposed to left hand side. Okay, then the simplification will be get the answer as 1792.41. So therefore 1792 bricks were placed in the cistern. Students, let's discuss exercise 13.5. Fifth sum. An oil funnel made of tin sheet consists of 10 centimeter long cylindrical portion attached to a frustum of cone. If the total height is 22 centimeter, diameter of the cylindrical portion is 8 centimeter, and the diameter of top of the funnel is 18 centimeter. Find the area of the tin sheet required to make the funnel. Actually this is here given that measurements. Okay, so we know that the total height of the funnel is 22 centimeter. At the same time here given the height of the cylinder is 10 centimeter. So that means the remaining height of the funnel is 12 centimeter. The frustum portion is 12 centimeter. At the same time, diameter is given, so the radius is 9 centimeter. And the diameter of the cylinder or end of the frustum portion is 8 centimeter. So the radius is 4 centimeter. Actually, here we need to find the area of the thin sheet. So that means here we need to find out the curved surface area. So to find curved surface area, here we must know the slant height of the frustum, because here the radius and height of the cylinder is, we know that. So we must find out the slant height, then only we can find out their curved surface area. So already we know that how to find out the slant height. So the slant height of the frustum part is square root of r1 minus r2 the whole square plus its square minus r2 the whole square plus its square. So we know the radius, subtract 9 minus 4. So already we discussed why we are subtracting here, because the shape is looking like as quadrilateral. If we subtract this 9 minus 4, see, this will be get a right angled triangle here. So then easily we can find out the slant height by using Pythagoras theorem. For that purpose only here we are using this concept r1 minus r2. So substitute the values here. So we get the answer is 13 centimeter. So the area of density equal to curved surface area of frustum part plus curved surface area of cylinder part. So you know the formula for curved surface area of frustum. So pi of r1 plus r2 into L plus 2 pi r2 h2. So h2 is denoted as height of the cylinder and r2 is radius of the cylinder. Okay, and this is the top of the funnel, the radius r1, and the r2 is, that is the end part. Actually, r2, this is radius of frustum and cylinder. Okay, end portion of frustum and the radius of cylinder. Then the substitute the values in the given formula. So at finally we get the answer as 782 4 by 7 centimeter square. So the area of 10 seat is 782 4 by 7 centimeter square.